Hello, this is Larry Stevens with the Spring Stewardship Institute in Flagstaff, Arizona. And today I'd like to tell you about a 2-year-long project that we had inventorying the springs of Grand Staircase-Escalante National Monument. I'll start out by talking about some concepts in springs ecosystem ecology. Springs here in the Southwest are quite abundant. Springs Online database has about 60,000 or so and counting. Those springs support about 1,200 species of springs that are springs dependent, plants, animals, invertebrates, fish, etc. But everywhere we find that springs are poorly mapped, and many are degraded by heavy anthropogenic use. In this project, we looked at the types and condition of springs. We used inventory and assessment methods that are well established and available on Spring Stewardship Institute's website. I'll look at a few case studies from some of the springs we visited and look at the assessment and recommendations we made to the monument. Springs are physical, bottom-up ecosystems. Geology and climate shape the aquifer. The aquifer produces water that emerges in some kind of site situation with a microclimate. The disturbance regime and productivity interact to create microhabitats, a template on which, through biogeographic processes, plants and animals can become established. So when you visit a spring, you see species that may or may not be interacting with each other, but you never visit the same spring twice. Through time, everything can change. And then humans step in and start extracting goods and services from the spring, water, recreational experiences, other resources, and can change the entire shape of the spring ecosystem. We've described this in a recent paper in Ecological Applications in 2021. So springs emerged from the black box of groundwater hydrology. More than 90% of the precipitation that comes into the Southwest is evaporated back out into the atmosphere before it has a chance to infiltrate into the ground. This places springs in arid regions at higher risk, especially where you have intensive groundwater extraction and use, and particularly under a warming and drying climate. The southern Colorado Plateau is dominated by nicely horizontally bedded strata, broken by occasional faults through the landscape. Precipitation is distributed across elevation with more rain at high elevations and less and more snow at high elevations and less at low elevations. When precipitation, especially in the form of snow at high elevations, melts and seeps into the groundwater follows pathways. Some of those pathways are short, as shown in the blue circles here, and some of them are longer. In general, those the springs that emerge from those groundwater flow paths come out as cool and high quality water at upper elevations. The longer the flow path, though, the more the water warms and becomes chemically enriched with solutes from the strata that it's passed through. Through analysis of springs all across Western North America and really across the world, Abe Springer and Ed Shank and I have been able to identify about a dozen different types of springs. Those that are lentic or slow flow systems, particularly in the Grand Staircase area, include helichrene or wet meadow springs. The common flowing springs, lotic flowing water springs types in Grand Staircase include hill slope, rheocrene, and hanging garden springs. Fewer hanging gardens, but hill slope and rheocrene are quite common. These spring types are defined on the basis of their geomorphology, not their vegetation or their use or water chemistry, but more on the geomorphology of the landscape. Over the past 2 decades, Spring Stewardship Institute has developed protocols for inventory and assessment of spring ecosystems. We divide these into 3 levels, really. Level 1 is simply georeferencing, understanding what the spring type is and where it's located. Level 2 involves a 1 to 2 hour visit by 4 experts to do inventory and assessment of the site. Level 3 work would involve springs that are selected for restoration or intensive research, etc. So within the Level 2 surveys that we've been able to do in the last 2 years in Grand Staircase, we've looked at a suite of variables, and those include the geography of the site, taking photography and creating a sketch map, documenting the site conditions, calculating the solar radiation budget for the site. Some springs are heavily shaded by cliffs and whatnot, and that makes their microclimates quite different than those that are not so shaded. We also look at the geomorphology, the microhabitats that occur there, the flow, the water quality, all the plant species we can detect in that 2 hours of investigation, the vegetation structure, all fauna, invertebrates and vertebrates alike, and then the sociocultural elements and the human impacts on the site. During a level 2 inventory, we conduct a Springs Ecosystem Assessment Protocol, what we call SEAP. This involves 6 categories with 42 variables. We look at the condition versus the risk of each of those variables, and we score it from a 0, meaning low condition or low risk, to 6, high condition or high risk. The variables, the categories that we're looking at there involve flow, geomorphology, habitat, and biota, or the species. Those are natural resource values that can be kind of looked at, evaluated, analyzed against the human impacts at the site. And then we also have a category of administrative context. The administrative context may override all the natural resource values at the site, because the steward is the individual who has the right to manage the spring as they see fit. The spring is their property. So the administrative context may override natural resource values. This method is conservative, it involves expert judgment, but it's quantitative, so it's useful for prioritization particularly, and for establishing a monitoring schedule, and for advising the steward. It's also quite efficient once the team is trained up on how to do it. So it's a useful result of the inventory, level 2 inventory that we do. Here's the Grand Staircase-Escalante National Monument boundaries. In doing this work, we initially pull together all the information we can gather on where springs are located. Use USGS maps, reports, research that's been done. We interview old-timers and people that are knowledgeable about the landscape, and try to pull together all the information on where springs have been reported to occur. Then we go out and develop a logistics plan for how to get to them. The green dots here are sites that we have inventoried over the course of the last 2 years. The yellow triangles are unverified sites that we have reports on, but we haven't been able to get to. And then we have a few sites that were verified along the way as we pass through the landscape. Let's go through a few case studies here. First, we'll look at a Rio Green spring. This is Neath Spring. It's in a channel, and it's heavily manipulated. It's been trenched to a depth of about 1.5 meters through its old course, and been piped to a large tank system. It's got a natural resource condition of 3, which means it could be rehabilitated, and the risk scores are pretty high there. The landscape has been pretty heavily modified. Jumping now to a Hanging Gardens. This is Adams Alcove Seep, a site that we discovered as we were traveling through the landscape. Its natural resource condition is 3.7, meaning it's in pretty good shape. It is right along a wash and gets some impact from roads there. And it's got a natural resource risk score of 2.9, fairly high, but still manageable. Restoration could be done at this site if the managers chose to do so. Hanging Gardens are relatively rare in the set of springs that we've been able to look at so far in the landscape. Moving now to a Helichrene spring. This is a wet meadow site called Sand Spring in the northeastern corner of the monument. Here, there is a long-term legacy impact of livestock grazing on the site with a fair amount of landscape alteration. But the BLM has very wisely, we think, fenced this off. They've directed water outside of the wet meadow to a tank system for livestock and wildlife, and very well protected this very large wet meadow. So it has a high natural resource condition score and a relatively low risk score. Monitoring of the fence, making sure the fence remains intact, would be a good idea here. Rather in contrast is Finn Little Spring, a helichrene that's not fenced and has very, very heavy livestock impacts on it, many non-native plant species here, and as you can see, quite a bit of trampling of the wet meadow habitat. Consequently, it has a low natural resource condition score and quite a high risk score. As we visit springs that have been reported in the landscape, we sometimes come across sites that have not been reported. An example of that is Pinnacle Cienega Springs here in the northwestern corner of the monument. It's about a 7.5 acre site, a great big wet meadow with a couple of rare plant species and a relatively rare dragonfly species, Sympetrum danae. Now, although Pinnacle Cienega Spring has a high natural resource score, it's also got a fairly high risk score. The site is very heavily impacted by livestock, and it's also beginning to be incised by Henryville Creek. And the incision here is of kind of a process that eventually will sap out the water of the helichrine and dry it out. So this is a concern for conservation of this site. Conservation measures that would have to be taken could be quite expensive here, adding to the high risk score, because you'd have to actually re-elevate the base level of Henryville Creek to really preserve this site. In our initial work on Grand Staircase, we found reports of 284 springs. As we traversed around the landscape, we've located 13 sites that were not springs, meaning they've been fully mismapped. We were able to survey a total of 61 sites. We still have not visited 187 reported sites there, but we're getting to a point where we are beginning to understand the status and distribution of springs in the landscape. From those inventory and assessment data, we're able to put together a graph of the natural resource condition versus the risk scores, which is shown in this graph here. Typically, this is a cloud of points that is sloping down to the right. And the graph, again, with the axes from 0 to 6 for condition, 0 to 6 for risk. The upper left corner tend to be sites in which they have low natural resource condition scores and high risk scores, meaning that the managers typically kind of throw up their hands at those sites. Well, the site is so altered that really we can't do very much to it. The management cost would be too high. The lower right corner in green there of the graph those are sites in which they have sites that have high natural resource condition scores and low risk scores. So those are sites that are in good shape. They actually probably don't need very much attention, occasional monitoring perhaps, and they might be useful as a sentinel site perhaps. In the middle though are sites that could benefit from management. This analysis and approach is based on the technical data. It's not based on what the manager's issues and needs are. How accessible is the site? How much is it going to cost? What's the urgency associated with each of the points in there? That requires a separate discussion. So this SEEP analysis is just the first step in terms of advising management based on the information gathered from the level 2 inventories. So in summary, we've now visited about 1/4 of the springs in the monument landscape. We find that after doing inventories and assessment on those, about 2/3 of them could benefit from management actions. Most of the impacts have to do with livestock grazing and flow diversion. And some of those impacts are relatively easily and inexpensively rectified to benefit the long-term sustainability of the landscape. Springs are important keystone features of the landscape, affecting the integrity of the surrounding uplands, and so much of the wildlife comes into those springs for their water sources. We look forward to working more with the monument staff in the future. They've been very helpful with the work on this project, and I'd really like to thank our SSI staff, Jerry Ledbetter, Andrea Hazelton, and our other staff members for their hard work on this in this landscape. And I'll happily take any questions. Thank you.